Hey everybody, welcome to another Con Support video. This one's on rates and proportional relationships. Okay, let's go. So let's zoom in here a little bit. All right. It says slow and steady wins the race. The leatherback sea turtle is the fastest known reptile with a maximum speed of 21.92 miles per hour. Which of the following equations, where d is distance in miles and t is time in hours, represents a speed that is less than that of the leatherback sea turtle? So just so we're all clear, the leatherback sea turtle moves at 21.92 miles per hour. So that means that your relationship of y over x is going to be miles on top and hours on bottom. So your output value, your y, is going to be miles. The input value is going to be hours, right? So your dependent variable is going to be the miles, and your independent variable is going to be the hours. So basically, if you're thinking about this situation here with d and t, right, the miles per hour is the ratio of distance over time, so it'd be d over t, right? So that's kind of the setup here. So 21.92 is the k, which is the ratio of d to t. And so when we're looking at the equation for this, right, it's going to be distance, output, okay, is equal to the ratio of distance over time, which is going to be 21.92, right? Times time input, right? So it's going to be this one here would be 21.92 as your multiplier, your constant proportionality. So it would be d equals 21.92t, right? So when we're looking at these examples, we're just trying to compare them to d equals 21.92t. And so we're asking ourselves which one is a speed that is less than that of the leatherback sea turtle. Now all that means is that the multiplier is smaller, right? So you're looking for a multiplier that is less than 21.92. So here the multiplier is 2.192. Obviously that's less. So that's slower. The next one is 20, which is less. So 20 is less than 21.92. The next multiplier here is 22. Now 22 is more than 21.92, so that would be faster. And then 30 is a faster multiplier, obviously, right? So the two that are smaller multipliers, which means the feature is going slower, would be d equals 2.192t and d equals 20t, because this one would be 2.192 miles per hour, and this one would be 20 miles per hour. And that's it. It says Jason has applied for 2 summer jobs, one as a lifeguard and the other as a camp counselor. The lifeguard job is 3 days a week and pays the following as shown in the table below. The pay rate is the same on each of the 3 days. The camp counselor job pays $8.75 per hour. So the camp counselor job pays $8.75 per hour, where hour is the input and dollars is the output. So what you'd end up with there is a situation where the equation would be y equals 8.75x, with x being the hours and y being the dollars. In this situation, it says which job pays at a higher hourly rate? Well, all we're looking to see is which rate is higher than 8.75 per hour. Now, if you worked 6 hours here on Monday, right, then this situation here, this is kind of funny because it says which job, but it doesn't actually describe the jobs here. It just says Monday, Tuesday, and Wednesday. That's pretty funny. And let's just choose one answer: the camp counselor job, the lifeguard job, or the two jobs pay at the same rate. Okay, I'm assuming that this is this is information related to the other job, right? So the lifeguard job is 3 days a week. It pays the following as shown in the table. So this is the lifeguard job, right? And then this here is the camp counselor job, $8.35 per hour. And now it makes sense. Okay, so anyways, so this situation here, let's just check the rate. So you want to think about dollars over hours. So you're going to do the $54 divided by the 6 hours to get the dollars per hour that this is paying. So if you just do that on a calculator, you'll see the results. So let's do it. So obviously 54 divided by 6 is 9. So I think you guys can probably do that in your head. But 54 divided by 6 is 9, right? So that's going to be $9 per hour. Then here, is it consistent? Is 4 times 9, 36? Yes. Is 8 times 9, 72? Yes. So here you're getting paid $9 per hour, whereas in the other job he's getting paid $8.75 per hour, which is a higher rate, $9 per hour. So the table is a higher rate. You're getting paid $9 an hour, which is more than the 875. So the table here represents which job? Okay, the lifeguard job is 3 days a week and pays the following as shown in the table. So that's the lifeguard job. So the lifeguard job pays $9 an hour, whereas the camp counselor job only pays $8.75 per hour. So it says, which job pays at a higher hourly rate? You would say the lifeguard job. Okay, Andre loves to bake, and plum tarts are his specialty. Plums are on sale for $3.25 for 2 pounds at the farmer's market. At the supermarket, plums are being sold according to the following equation, where P is price in dollars and L is pounds. So they're basically saying that you input the pounds and you output the price in dollars. And it's $1.75 per pound. Okay? Where do plums cost less, at the farmer's market or at the supermarket? Well, at the farmer's market, it's $3.25 for 2 pounds, right? So that means if you take the dollars and divide it by the pounds, you're going to get the price per pound, which is what you want. So half of $3 is $1.50, and half of 25 cents is 12.5 cents. So you're looking at 12.5 cents plus $1.50, or $1.62.5. So the farmer's market is charging $1.62.5, right? 1.625, right? For each pound, right? That's the price per pound. Whereas the grocery store is selling $1.75 per pound. So in this case, actually, the farmer's market is cheaper, right? So it says, where do plums cost less? The farmer's market. Okay, the unit rate of change of y with respect to x is the amount y changes for a change of 1 unit in x. Okay, is the unit rate of change of y with respect to x less than the equation y equals 6.5x, or in the graph below? Well, if we take a look at this graph here, we want to look at identify an exact point. And I'm looking at that point right there. That looks like an exact point. So that's telling you that when x is 2, y is 7, which means that if it's at a constant rate and proportional, that when you cut the 7 in half, you got to get the 2 in half. So when x is 1, y should be 3.5. And that looks like exactly what's going on there. So this is basically saying that the unit rate is, as we increase the x by 1, we're increasing the y by 3.5, which basically means the order pair 1, 3.5. So that's the situation there. So this would be an equation y equals 3.5x. This one up here is y equals 6.5x. It says choose one answer. The unit rate is less than the equation. No, the equation's more. The unit rate is less than the graph. That's true. The unit rates are the same. Well, they're definitely not the same. So the unit rate is less than the graph is the correct answer there. All right, the next one says the unit rate of change of y with respect to x is the amount of y changes for a change of 1 unit in x. The table below represents a proportional relationship with a constant unit rate of change y with respect to x, which describes a greater unit rate of change y with respect to x, the equation y equals 4.5x, or the table. Well, if you look at the table, right, the multiplier is going to be the ratio of y over x, because the constant of proportionality is just that ratio of output to input. So if you just do 9 divided by 2, you're going to get your multiplier. So 9 divided by 2 is 4.5, so 2 times 4.5 is 9. 18 divided by 4 should be that very same 4.5, and it is. And 4 times 4.5 is 18. And 27 divided by 6 should be 4.5, and 6 times 4.5 is in fact 27. So we can see that in the table, the relationship is y equals 4.5 as well. Y equals 4.5x. So they're actually the same. Usain Bolt is considered the fastest person on Earth. He holds the record for the fastest 100 meters, which he ran in 9.58 seconds in 2009. We'll assume that Bolt ran the race at a constant speed. Which of the following equations, where t represents the time in seconds and d represents the distance in meters, describes a speed greater than Bolt's record-breaking speed in 2009? So what you're looking at is you want to have a higher multiplier than 9.58 times the seconds equals the distance, right? So basically you're looking for 9.58 t equals d as something that you're comparing against, and you want something that's greater than 9.58 t. So if we're looking at this, all of these are greater than 9.58 t. So they're all going to be faster than 9.58 t, because in all of these situations, the rate of speed is going to be faster than 9.58 meters per second. Oh, that's funny. Give it another try. I guess I made a mistake. What did I do wrong? Usain Bolt is considered he holds the record to the fastest 100 meters. He ran 9.58 seconds. This is 9. Okay. Are the units different? We'll assume that Bolt ran the race at a constant speed. Which of the following equations, where t represents time in seconds and d represents distance in meters, Describe a speed greater than Bolt's record-breaking speed. Oh, silly me. It's not 9.58 per second, right? Meters per second. He was running at 9.58 seconds in 100 meters. I don't know what I was thinking. So anyways, so in this situation, if you're thinking about what's going on here and you do it a little more carefully than I just did it, right? We know that the output is going to be meters. The input is going to be seconds. And what we're going to have here is 100 meters in 9.58 seconds. So in order to find the ratio of meters per second, you'd have to do the 100 meters divided by the 9.58 seconds. So what you have to calculate there is 100 divided by 9.58, and 100 divided by 9.58 is going to be 10.438. So basically 10.43. All right. So you're looking for a multiplier that's bigger than 10.4 but less than 10.45. So 10.45 is the greatest because it's greater than 10.43, and so 10.43 is bigger than all the others, but not as big as 10.45. So that's why that's the answer. So silly me, I forgot to divide. I just took for granted that was 9.58 meters per second, and it obviously isn't. It's not even close to that, right? It's a different result. So it's 9.58 seconds for 100 meters, right? All right. Let's move on. This one says Charlie can type faster than any of his classmates. He took a test that showed he can type 700 words in 5 minutes. Okay, so he's typing at that relationship, 700 words in 5 minutes. All right. The funny thing is, it says the words per minute, right? But that would be in 700 words in 5 minutes. You got to figure out what the words per minute actually is. So it's not really in that unit yet. All right. It says the fastest recorded typing speed is shown in the chart below. We assume the speed is constant for the 3 minutes. Does Charlie type faster than the record shown in the chart? Okay, so let's take a look at it. So if we're looking at this situation here, we could make a table for it here so we can kind of go through and do this, right? So in this case, we're looking at not meters and seconds like the last problem. You'd be looking at the ratio of words per minute. So just to kind of keep this kind of consistent where you guys can see the results here. So if we did output of words and input of minutes, then the ratio of words per minute is going to be K, the constant. So in this case, it says 700 words in 5 minutes. So to find that constant, you just do 700 divided by 5, and that's going to give you the words per minute, right? How many words in every single minute. So if we do 700 divided by 5, we're going to get 140, all right? So what happens there is you get 140 words every 1 minute. That's called the unit rate, right? So this person, Charlie, is typing at 140 words per minute. Now, when we look at the table here, in 1 minute, this fastest time is 216. In 2 minutes, it's 2 times 216, and then 3 minutes would be 3 times 216, right? So what we're seeing is basically this ratio of 1 minute for 216 words is the fastest. And this person, Charlie, is only doing 140 words every single minute. So is he doing it faster than the fastest? No. It says, does Charlie type faster than the record shown in the chart? And the answer is no. No, Charlie types slower than the record speed. All right, so I made a mistake on that one problem because I was being a little silly. I think you guys get the idea.